Trig identities. There are times in higher math when we have complicated trig expressions that need to be simplified in order for us to be able to work with them. So we're going to learn how to use trig identities to change an expression to a different form. And you can see in these boxes, these are some identities. These are the ones we'll be using. The reciprocal identities you should already be familiar with. The sine and the cosecant are the flipped over of each other. Secant and cosine are the flipped over. Cotangent, tangent are flipped over of each other. The quotient identities for tangent and cotangent will be used more often than the reciprocal for tangent and cotangent. So although these are true, we're not going to use those often at all. It's these quotient identities for tangent and cotangent that we'll be using. The Pythagorean identities, there are three of those: cosine squared plus sine squared equals 1, and so on. And then the odd even identities tell you what to do if you have the trig function of a negative angle. When we're working with these identities, the following strategies are useful. You want to see if the expression in front of you is one of the identities so you can change it. The second strategy, and the one that we'll use the most often, is change everything to sines and cosines. Foiling is something that comes up sometimes. We often have to combine fractions, and sometimes we have to factor. And after every step, you have to run back through this list and see if there's something else you can do. So it's not necessarily you go down the line in order, except for maybe the first two, but you cycle through this list over and over again within one single problem. These identities are on Point Learning. You might want to print those out and have those in front of you as we go through this lesson, and it will be good to have it for your homework as well. So the first problem we come to says write the trig expression in terms of sine and cosine and then simplify. So they're trying to get you to practice that second strategy that I put the star beside, changing everything to sines and cosines. And we normally use that first box, the reciprocal identities and the quotient identities. So we have cosine, t, that already is a cosine, so we'll just leave that alone. And then tangent. So even though tangent is 1 over cotangent, that's not changing things to sines and cosines. That's why I marked those out. We're going to use the quotient identity that says tangent is equal to sine over cosine. Now we have a cosine on top and a cosine on bottom. Those can cancel, and we're just left with sine. And so then it's simplified. The next one, cosecant over secant, you would have to use reciprocal identities. Cosecant is the sine flipped over. The secant is the cosine flipped over. And remember, when you're dividing, when you have a fraction, the bar in the middle means divide. So I'm going to unstack these fractions and write that as 1 over sine divided by 1 over cosine. When you divide fractions, you flip and multiply, so that would become 1 over sine times cosine over 1. Now we have two fractions to be multiplied, multiply tops, multiply bottoms, and we have cosine over sine. Now we want our answer to have as few terms as possible. I'm going to rewrite this. And so if you look under the quotient identities, you can see that cosine over sine can be written as cotangent. So that's one trig identity, one trig function instead of two. So just cotangent is simpler than cosine over sine, and that's what we want. We want in the simplest possible form. Sine squared times 1 plus cotangent squared. As is true with many of these problems, there's more than one correct way to start this. You could change cotangent squared to cosine squared over sine squared. From the quotient identities, cotangent is cosine over sine, so if it's squared, then both the cosine and the sine can be squared. But there's also, in the Pythagorean identities, one that says 1 plus cotangent squared equals cosecant squared. So cosecant squared is a more simple form than cosine squared over sine squared. So I'm going to use that identity. You would still get there eventually with the other one. After you've worked these a lot, you start to see ahead and figure out ahead of time what would be the simplest form. So that's why I know to use the cosecant squared. So I change sine squared theta to, leave it alone because it's a sine, and then 1 plus cotangent squared is cosecant squared. Now cosecant is 1 over sine. So cosecant squared is 1 over sine squared. Now I have a sine squared on top, a sine squared on bottom. Those cancel, and I'm just left with 1. You want to keep going through your list of strategies. The more problems you do, the more you'll begin to recognize and memorize the identities, and the faster you'll become, and the easier these will be for you. The next one is secant minus cosine over sine. So if I think about the list, there's nothing here that's on my sheet, so I'm going to change everything to sines and cosines. Secant is 1 over the cosine. And then I already have a cosine, so I'll leave that alone. And the bottom is already sine, so leave that alone. Now on top, I would need to combine those fractions. That's really cosine over 1. And to subtract fractions, you need a common denominator. That would be cosine, so if I put a cosine on the bottom, I have to also put a cosine on the top. So when I do both fractions on the top, I would have 1 minus cosine squared over cosine. I combine the two top fractions with my common denominator. On the bottom, I have sine, and I can put that over 1. That's going to make things easier for us in a minute. Remember how we have a bar means to divide. And another thing we might notice is the 1 minus cosine squared. If you rearrange the Pythagorean identity that says sine squared plus cosine squared equals 1, if you subtract cosine squared from both sides, you have sine squared equals 1 minus cosine squared. Or if you subtract sine squared from both sides, you have cosine squared equals 1 minus sine squared. You might want to write those beside that Pythagorean identities box, because that happens a lot where you run into this identity but it's rearranged. So 1 minus cosine squared in a more simple form would be sine squared. So I'm going to unstack my fractions. I have sine squared now over cosine divided by sine over 1. When you divide fractions, you flip and multiply. Sine squared over cosine times 1 over sine. I can cancel out 1 sine. Now I have sine over cosine, and the more simple form of sine over cosine is tangent. Tangent x plus tangent cubed x. If you look through the strategies, you might be tempted to go ahead and change this to sines and cosines, but look through the whole list. One of the strategies is to factor, and notice that both terms have a tangent in it. So let's divide out a tangent, greatest common factor. Divided out of the first term, anything divided by itself is 1, plus, and then if I have 3 tangents and I divide one out, I have 2 left. Now 1 plus tangent squared is one of the Pythagorean identities. 1 plus tangent squared equals secant squared. Now I can change everything to sines and cosines. Tangent is sine over cosine. Secant is 1 over cosine. So if it's squared, it would be 1 over cosine squared. And really we could make that sine over cosine cubed when we multiply the fractions. That would be okay. Really, there's nothing more you could do with that. You could have left it tangent secant squared, because those are both about equal as far as how simple they are. So some of these have more than one correct answer that I would accept. Now, when you're asked to verify the identity, this is a little bit easier because at least you know what your answer is supposed to look like. You know when you can stop. The previous ones, like the one I just did, it's a little bit iffy about where you want to leave your final answer, but these are definite. So as soon as the left side looks like the right side, you're finished. All right, same strategies though. Let's change, nothing there is on the sheet. I can't factor or anything like that. None of those things I see are just an identity. So I'm going to go ahead and change everything to sines and cosines. I already have a cosine, so I leave that alone. Secant is 1 over cosine. Tangent is sine over cosine. Now on the right side, cotangent is cosine over sine. The fraction on the left up at the top, the cosines would cancel. And again, I've got a fraction over a fraction. I'm going to unstack that and write that as 1 divided by sine over cosine. When you're dividing fractions, you flip and multiply. That would be 1 times cosine over sine. And when I multiply by 1 then, the left side looks like the right side, and so I can stop. I'm finished. I've proven that this is true. That's what verify means. The next one, look at all those negative angles. Remember, one of the little boxes was called even-odd identities, and it showed you what to do with negative angles. So cotangent of negative alpha, it would have the same result as tangent of negative alpha because they're the flipped over of each other. Tangent of negative alpha, the negative just moves out front, so that's going to have the same effect with cotangent. So negative cotangent alpha. When it's cosine negative theta or negative alpha, the negative just goes away. With sine, it becomes negative. And again, I'm looking at the even-odd identities to figure this out. And then negative cosecant alpha. Now I've handled that. I can change everything to sines and cosines. I've got negative cotangent is cosine over sine. Already a cosine, leave it alone. And then cosecant is 1 over sine. Multiplying the two fractions, I have negative cosine squared over sine minus sine equals negative 1 over sine. Let's put that over 1. I'm trying to subtract fractions. I need a common denominator, which would be sine. So sine on the bottom, sine on the top. Negative cosine squared minus sine squared all over sine equals negative 1 over sine. Now again, like I said, keep cycling through the list of strategies. We go back and look at the identities, and the Pythagorean one, there's one that says cosine squared plus sine squared equals 1. Everything's positive. We have everything negative. Look at what we can do. We can factor out a negative 1. That would change to a positive. Now we have what's on this sheet as an identity. Cosine squared plus sine squared equals 1. So it's just negative 1 on the top. Now it looks like the right side. So it's finished. And I've given you homework to match each one of these examples because these are hard to figure out at first when you first start learning these. So really rely on these examples to help you with your homework. In parentheses, sine x plus cosine x all squared equals 1 plus 2 sine x cosine x. Everything already is sines and cosines. None of those things are identities. So one of the strategies is to FOIL. When you have something in parentheses squared, you write it twice and you FOIL it. And then the right side, there's not really anything we can do with that. So filling that out first, outside, inside, last. First would be sine squared. Sine times sine is sine squared. The outside would be sine cosine. The inside would also be sine cosine. So I have a total of 2 sine cosine. And then last would be cosine squared. On the left side, if I rearrange a little bit, I've got sine squared plus cosine squared, which equals 1. So 1 plus 2 sine x cosine x. Now the left side looks like the right side. And so that one's finished. Sine over cosecant plus cosine over secant equals 1. So we need to change everything to sines and cosines. That would be sine. And I'm going to go ahead and unstack it. Divided by, and cosecant is 1 over sine, plus cosine divided by, and secant is 1 over cosine, equals 1. When you divide fractions, you flip and multiply, so it would be sine times sine plus cosine times cosine. Sine squared plus cosine squared equals 1. Now I know that's the identity, but take that one more step and make the left side look like the right side. Sine squared plus cosine squared is 1, and then the right side is also 1, and now it's finished. There's often more than one correct way to work these. As long as your steps are correct, I'll be able to follow what you've done, and you'll be able to get full credit. Some people can work a lot of this in their head and take shortcuts, and if you can do that, that's fine. I should be able to follow that. You need to show, some work. But if you don't do it exactly the way I do it, but you're still getting them right, that's fine.